Gude! This video topic has been voted by my great YouTube community. Thank you! Today's topic is how you can clone your own voice to an artificial text-to-speech voice model on Microsoft Windows with Coqui text-to-speech. As Coqui TTS is officially not supported to run on Microsoft Windows, creating this video for you took lots of time for research and try and error and try and error and try and error. If you would like to support my work, please subscribe to my channel. And as you can see by the statistics, around 90% people watching and hopefully enjoying my videos have not yet subscribed to my channel. So if you are part of this group, please subscribe to my channel, hitting the notification bell. Give this video a thumb up and let me know in the comment box below what do you think on this video. This would really help me and this channel a lot, so thank you for that. One of the first things to do is satisfying some required dependencies, such as visual build tools for C++ development, or Python, I'm going to use Python 3.8 in my case, or eSpeak or TensorBoard. After the short introduction, I will show you everything that is required step by step. And now, let's go!
Gude! Hacky, techy, nerd stuff. Open voice enthusiast. Open voice, open future. Let's start by satisfying some required dependencies. In this case, I'm using my desktop computer with Windows 10 and a GPU graphic card, an NVIDIA GeForce GTX 1050 Ti with 4 GB of GPU memory. The process I'm going to show you in this video should work the same way in CPU-based training. Let's start by satisfying our Python requirements. Coqui TTS supports Python 3.7 up to 3.10, and I'm using 3.8.10, and there are two ways to install it. On the one side, you can simply use Microsoft's App Store, open it, search for Python, and you can choose between Python 3.11, which is not supported yet, and 3.7. So you can use Python 3.8 and simply install it by hitting that install button, or you can install it by using the direct package download by Python webpage, which I personally prefer. So you can hop on to Python.org, the download section, Windows, and version 3.8.10. And I'll put links to all of the web pages I'm calling in the next minutes in the description box below. So scroll down a little bit, and in my case I'm using the Windows installer MSI package for 64-bit. Downloading it and just run it. As I've installed it already, click modify. I've checked all options, click next. Click next. Python installation successful. Let's close it. Then let's install eSpeak-ng. So let's open eSpeak-ng releases on GitHub. Latest version latest version 1.51. And again, let's download the MSI package for 64-bit. Run it. Okay, change. Pretty simple installer. So installation successful. And we need the Microsoft build tools. So let's click download build tools. Yes. Click modify. And the important part is that you activate the checkbox desktop development with C++. As I've installed this already, I can skip this one, but please make sure you install these desktop development C++ libraries. And we can just check that everything is installed by checking our installed programs. So first of all, let's see Python. Okay, Python is installed. Let's see eSpeak. eSpeak is installed. And in my case, I've installed NVIDIA CUDA. So let's see the CUDA version, I've installed version 11.7. So let's start with the cool part and open our command line prompt. And I've already created a directory. I'm going to show you this one called TTS training in my user home directory, containing just a simply modified Coqui TTS training receipt. We will go into more details on that later on. And I've prepared a Thorsten-Voice data set in that well-known and supported LJspeech file and directory structure. So, and that's all I've prepared for now. Now let's go back to our command prompt, switch into that directory, check our Python version first. So 3.8.10 is installed. Now let's create a Python virtual environment. So run python -m venv dot. And as you can see in the file explorer, there are some files created or directories created for that Python virtual environment. So to activate this, and as you can see by the TTS training prefix, which is basically the directory name we are in at the moment, my Python virtual environment is now active. Let's see which Python packages are already installed by running pip list. So pretty simple pip and setup tools. I will add the wheel Python package and update setup tools. So let's run pip install setup tools wheel -U for upgrade. See pip list again. And here we are. So, and as I've said, I train using NVIDIA CUDA for performance reasons. I have to install special libraries for Torch audio. So for that, let's go back to our browser and open a PyTorch download page. And I select the latest PyTorch build 1.13.1 for Windows operating system, pip package management, Python language, and CUDA 11.7. Just copy the command, go back to our command line prompt. Make sure you are still inside your Python virtual environment and run the pip3 install command. So this will download and install special Python packages for CUDA 11.7. Installation finished. So let's see our good old friend pip list. And now we can see that we have 3 Python packages called Torch, Torch Audio, and Torch Vision in a special version for CUDA 11.7 support. But there's one more dependency that should be satisfied, and this is called tensorboard. This is not required, but tensorboard can monitor your training process. So I recommend you to install tensorboard just to keep an eye on your training progress. First of all, let's install Coqui TTS itself and then add tensorboard dependency. How do we install Coqui TTS? So let's go to Coqui TTS repository on GitHub. Latest version is version 0.11.1. You can clone it by using Git tools, or you can just simply download the code by using the browser download. This is totally up to you. I'm going to choose the source code download for now. Let's open it in the zip file and simply save it in our TTS training base folder. So now we have that TTS version folder. Let's go back to our command prompt and simply run and build and install it by running pip install -e dot. Coqui TTS installation is still running, downloading some dependencies and installing lots of required Python packages. Oh, looking good so far. So installation is finished. And again, let's take our lovely pip list command to see if the TTS package is installed in our Python virtual environment. And this is looking great. So we have TTS installed in the latest version 0.11.1 in my user home directory. I would like to install tensorboard to keep an eye on training progress. So for that, let's run our pip install tensorboard. And once this is done, we have satisfied and installed everything and we are ready for training. So now let's go back into our base directory and let's run that TTS training receipt. I will give you a more inside view soon. But first of all, let's just check if the script is running. So train width running as Python script. So this is looking good so far. So as you can see, number of GPUs detected 1. So if you have more than one GPU available, you can use a so-called distributed training. But in my case, I have just one GPU, so this is detected correctly. And the first step while running the training is to pre-compute the phonemes. Because I've set it to phoneme, not to character-based, but to phoneme-based training. All WAV files and transcribed text from my voice dataset will be converted to phonemes. And now let's take a look to the Windows Explorer, to our base folder TTS training. You can see on the one side a phoneme cache directory with lots of files containing these calculated phonemes using eSpeak-ng as we've installed as a required dependency. And we have a so-called output folder that's called the run name, so with Thorsten-Voice, with Thorsten-Voice, with the date timestamp on starting the training run. So while training is running in the background command prompt window, let's give these receipts a closer look. For that, let's open our Coqui TTS repository. And you can see these receipts folder. Before these receipts by Coqui TTS, we had just one config.json as input file containing hundreds, and I really mean hundreds of configuration key value parameters. And now by using this trainer or receipt configuration, you just have to adjust the values you would like to differ from default values. This makes configuration and starting the training process really more easy. To get an overview, you can take a look and, for example, let's take the famous LJspeech. And here you can see lots of prepared receipts for TTS or voice encoder or so-called vocoder models. I can recommend you starting with the WITS TTS model, because WITS contains the TTS model and the vocoder model all in one. So you get a really nice quality with just training one model. So if you take a look to this folder, you can see one train WITS file. So this is one possibility to start from and adjust with your individual user settings, so directory structures, paths, sample rates, whatever type. If you would like to follow the content on this video, I've taken this file and made some adjustments for my Thorsten-Voice dataset. So just let's hop on to my Thorsten Müller GitHub repository and then to the Thorsten-Voice repo, and inside the YouTube folder I've created this train width WinPy. This is identical with the file I've started training a few seconds ago. So let's just take a look. And by the way, okay, training is still running. Let's keep this one a little bit in the background to see that everything is still running correctly. So what do we have here? This is mainly based on the default Coqui TTS receipts with some adjustments. Obviously, my voice dataset is in that LJspeech file and directory structure. Because we are on Windows and backslash is an escape character, please make double backslashes in the case of your path separators. The rest, audio configuration, sample rates, and here the run name. You can give each TTS training run a name, and I really recommend you, I've learned it the hard way, do not use any special characters, at least no white spaces in your run name. Because as I've said, the run name, in this case with Thorsten-Voice, will be part of your output directory. And if you take a white space in that run name in the configuration, you have white spaces in your directory. And this does not make any fun at all. So try to avoid special characters in your run name. Batch size is depending on your available hardware configurations. As I've said, I'm going to use phonemes. If your language, or let me say, use phonemes should be available for really lots of languages support using phonemes with eSpeak-ng. If this is not the case, you can switch to use phonemes false and will use character-based training. So setting the phoneme language code, DE for my German model, the path name phoneme cache, as we have seen in the TTS folder. This is this one here, phoneme cache. And let's go a little bit down. We have these test sentences here. And this is an important section. We would like, or at least I would like, to hear how the voice quality is improving with further training steps and further training time. And using this tensorboard, we can listen to these phrases in multiple training steps. So here you can enter phrases in your local language that you would like to listen and get an idea on how quality is improving over training time. I will put a link to the Coqui TTS documentation because this is just a really rush overview. I have made a special video on configuration management in Coqui, which I will also link. So please check out the video description. And by the way, please do not forget to give this video a like. Let's discuss in the comments what do you think. And if you have not, please subscribe to the channel, as this would really help me and the channel a lot. So thank you for that. And this is basically it. But because we are training on Windows, and Windows has some specialties when it comes to multi-threading and how processes are being started, these last lines are important. So special, as it's written here, needed for Windows. So take these lines, line 91 up to 94, and at the beginning, line 12. So the definition of a main function. I did not figure out this myself, but I will put a link to an issue of Coqui TTS. So let's open this one. And if you scroll down this closed issue, so Arrowgall has written, we don't support Windows currently. That's true. But in this train TXT, there's the base of this, let me say, of this helpful multiprocessing required change. Feel free to take this or one of the other Coqui TTS receipts as basis and make your personal adjustments on that. So, and as we can see in the background, training process is still running. This is good. And let's start a new command line prompt to run our tensorboard. Maybe should close some windows to keep it nice and clean. So let's keep this one open. Just because it's training on Windows, we do not need every window open. So let's close the last one. So let's switch in our base folder, and important, before running tensorboard, let's again activate our Python virtual environment. Now let's go into our output folder, so training run name, and the timestamp, and here run tensorboard --log dir for directory equals dot. So let's open our local host on port 6006. And here we can see some alignment figures. We can see lots of graphs showing training progress. Let's see here. We are just at step 180. So audio quality, okay, is not existing at the moment. We can see, let's skip the audio tab for the moment and go to the text tab. And here we can see complete configuration JSON file. As I've mentioned, hundreds of key value configuration parameters. And that's the complete config JSON. So this is identical to our output folder config JSON. So let's open this one. And let's make it bigger. As you can see here, if I scroll down till the end, we have over 250 lines of key value configuration. So, and honestly, I think using this training receipt with just the relevant configuration values with less than 100 lines of code, including comments, is way better than using the pure config JSON file. So now let's go back to our tensorboard, audio tab, and we can see we have step 210, and we see test audios. So we have a test audio 0, 1, 2, 3, and 4. So 5 test audios in total. And let's scroll through our config JSON, and we have these test sentences here. And we have 1, 2, 3, 4, 5. So this makes totally sense. We have defined 5 test phrases, and here we have 5 test audios. So if I play these back on step 240, and I will put the headphones off because this will mainly be noise, but just to give you an idea, there is audio, or not voice, but random noise generated at step 240. Okay, I guess now you know what I mean. So you need lots of training steps until this becomes actual voice or really high quality voice. Let's go back one time to our Explorer. And as I've mentioned, we have this config JSON and we have a best model.pth files. This combination, these two files, a model, PTH, and the config JSON, these two files will be later on used to synthesize audio either way on the command line or by using Coqui's integrated TTS web server. To show you the concept, TTS-server. Skip any parameters, it will use a default English model. But let's call it with help. There are command line arguments like model path, configuration path. So let's give this one a look. So we have a config path and a model path. And these two files, just for the fun, let's run a TTS server with that model file. But honestly, this is just noise. It's just to show you how things work. I will keep up training for some hours to give you maybe a better idea. But training takes time. So let's run it. TTS-server --config path. I'm already in my output folder, and this is the config JSON file, and the second argument is model path. So model path, and this is, let's take the best model and run this. So this will start up the server process, the locally running. We are still always on localhost. The server local process reading the best model file and the config file that has been created from the training run. So let's open on port 5002, localhost 5002. And here we are. So this is the simple Coqui TTS web server front end. And let's run Das ist ein Test. So regardless which text I'm entering at this little training process or progress, this will sound absolutely crazy. So let's synthesize the audio. Okay, as expected. So I will stop this one. This is not really helpful at the moment. Let's close it. Close this tab. Check our server progress or training progress. Let's make a pause. Grab yourself a tea, a coffee, a water, whatever you like. So it's nearly 2 hours since I've started the training process. So let's give the tensorboard and the audio samples a new try. So let's run a new command prompt again. Go into our base folder, activate our Python virtual environment. Go into the output folder and run our tensorboard. Open localhost port 6006. And first of all, let's check our text tab. And here we can see the test phrases once again. And after just 1 or 2 hours of training duration, you will not be able to recognize the audio. But what I would like to show you is that the phrase number 1 is the longest phrase, at least. So let's go to the audio tab. And as you can see, we have reached step 3750, which is by far not enough. But at least we can see that the first audio sample with 7 seconds duration is the longest. So 7, 2, 4, 3, and 3 seconds. So this seems to make sense at least. So now let's play back the first sentence. Guess you can hear that there's plenty of room for further improvements. You can grab this button, go down to previous steps to see graphs and hear audio samples from previous checkpoints to get a comparison if training is going to the right direction. And as I've mentioned on the beginning of this video, doing this video took lots of time and efforts and research and try and error. So if you would like to support my work, please subscribe to my channel, hit the notification bell, click thumb up, give me feedback on this video or other videos on my channel in the comment box, and share my videos and channel with other voice technology enthusiasts. This would really help me and this channel a lot. And yes, that's it for today's video. I hope you like it, you found it useful. And if you like, we might see us next time. Bye!